Good day everyone, my topic is about four models and the hydrogen atom. At the beginning of the 20th century, a new field of study known as quantum mechanics emerged. One of the founders of this field was Danish physicist Niels Bohr, who was interested in explaining the discrete line spectrum observed when light was emitted by different elements. Bohr was also interested in the structure of atom, which was a topic of much debate at that time. Numerous models of the atoms had been postulated based on the experimental result, including the discovery of the electrons by J.J. Thomson and the discovery of nucleus by Ernest Rutherford. Bohr supported the planetary model, in which electrons revolve around the positively charged nucleus like the planets around the Sun. However, scientists still had many unanswered questions. Where are the electrons and what are they doing? If the electrons are orbiting the nucleus, why don't fall into the nucleus as predicted with the classical physics? How is the internal structure of the atoms related to discrete emission lines produced by excited elements? As we learned from the previous lesson, Balmer works on spectrum lines, and he established a mathematical relationship between the various absorption lines for hydrogen. Balmer wasn't able to explain it, but as we come to see, Niels Bohr is able to explain that and answer the question with his Bohr model. Bohr model came up with some key postulates. First, electrons orbit about nucleus in circular orbit under influence of Coulomb attraction to nucleus. It also supports what Rutherford stated, that the nucleus was in the center and the electron in orbit around the nucleus. Second, orbit angular momentum L is quantized, hence only certain orbits are possible. Second postulate is really critical, and if you look at the history of physics in the year 1900s and 1905, we had introduction of quantum thinking, initially with Max Planck's of black body radiation and Einstein on photoelectric effect. Bohr took them on board. He came up with postulate that electron E has an angular momentum which is L, and it is a quantized that the amount of momentum it has value. So therefore, only discrete orbits are allowed in this formula for angular momentum, where n is a number from 1, 2, 3, 4, 5 integers for a level of each orbit. H is for Planck constant, and 2 phi is also constant. Basically, what he is saying is, electron can exist in this orbit and another electron can also exist in this orbit, but it is impossible to exist anywhere in between, so it is quantized value or discrete. 3. Electron in stable orbit do not radiate. If electron is in that orbit, as long as it stays in that orbit, it doesn't radiate energy. It means that no gains of energy or no loss of energy. It is stable. 4. Electron change orbit by radiating larger to smaller, and also by absorbing radiation from smaller to larger. As you can see in the example, electrons radiated in other orbit will radiate energy as a result. And if the electrons absorb energy, it will go to the higher level or to the larger level. And lastly, electron change orbit by collisions. An electron can either up and down by collisions to other atoms. And this really helped to explain the spectrum lines of hydrogen. Remember the Rydberg formula and Balmer series? Balmer wasn't able to explain why the emission lines or absorption lines of hydrogen atoms and where they are. So if we look in the spectrum line of hydrogen atom at the Balmer series, where it can calculate using the Rydberg formula. The value of N1 here is end up with 2. In this case, the atoms of hydrogen is absorbing energy and those electrons are jumping into the energy level. And also, those electrons jump down back to the level 2. It will release a discrete amount of energy that will give a wavelength that corresponds to the red part of a spectrum. And if the electron jump down from 2, these wavelengths become smaller. It would get a higher frequency that corresponds to the orange part of the spectrum. For that, it would explain why you get or see this line in the spectrum. There are also hydrogen spectrum emission and absorption spectra in ultraviolet and infrared series. The ultraviolet series is referred to Lyman series, and the infrared series is referred to Fasan series. In Lyman series, the value of n is 1. In Fasan series, the value of n is 3. The Bhor model fits perfectly with the number that we're seeing in the spectra, but it only works for hydrogen. And that's the end of my topic. Hope you learned something.